Hello and welcome to this tutorial. My name is Chris and I'll be introducing in this particular tutorial it's Bezier Curve Animation in Blender and importing that into processing. If you followed along on a previous tutorial on this topic, I did cover working with Bezier curves and importing Bezier curve data into processing. The code that I've written in processing language actually extends off of that previous code set that I have. So if you have any familiarity with that, you may find quite a bit of similarity between that code set and the code that I've written in this case. I did make, in the case of importing data from processing, or actually from Blender to processing, I did make that actually a lot easier in the context that I've now included in my newest script. It's a CSV, or comma separated value table data set. And not only that, I've also included the ability of importing that data in terms of frame animation data and distinct curve set data. So if you'll just go ahead and follow along here, I'll explain how to kind of run the scripts and how to get things set up there in Blender and then going into processing. So the first thing is, and you may recall from the previous tutorial, that I do recommend, if especially you're using Blender as a Linux user, that you actually launch Blender from terminal. And the reason why you'd want to do that, again, for any new listeners there that aren't familiar with the procedure here, is that when we have any sort of feedback output, say errors or anything that may come up that are problematic to the script, or we want to copy down data for some sort of custom importation purposes that isn't already done in the scripts, you can find that data output, say from like a print line output in Blender. You can find that actually from the terminal screen that you launch Blender from. Windows and Mac users, on the other hand, may have in Blender a custom console toggle that will give outputs if you're running Python scripts in Blender. So the first thing is I've gone ahead and pulled up my terminal, and I'm actually in my directory, my Blender directory that's shown here, and I'm going to go ahead and launch the program. If you're familiar with Linux, you can launch any program with the // and then the file execution file, or the application name there. So for instance, I did a list of the files in my given directory that I'm situated, and that's with an ls command, and then // Blender. We can see the Blender shown highlighted in yellow, and there we go. We've got Blender launched, and we're starting here at the main load screen. So I'm going to go ahead and delete this cube by hitting the delete button. I'm also going to go ahead and get one other preference loaded really fast here, so that you can see or follow along with some of the keys that I'm pressing as I'm working here. And to get that loaded, I've just gone to user preferences, start the display, and there we go. So the first thing is that I am going to want to do a split screen. I will kind of go through this more rapidly. If you are unfamiliar with the procedure, you can watch my previous tutorial that kind of goes through, I explain it more slowly in terms of like how to load the scripts and all that good stuff there. So I'm going to my C processing folder, which is the folder that I've been working out of when doing work out of processing, but I've also included my in that processing folder where I've got my scripts written. I've also got my Blender Python files stored there. So in this case, I'm working with the last in series Bezier Curve Data Read 3. We'll want to load that script, and then we'll also want to load an additional script as well. And let me go ahead and get to that in just a moment. So I'm going to open up a new text block, and let's see here. We'll go ahead and open the next text block, and the last one is called Bezier Vertex Select Hook Add. This is a convenient script, and I'll explain it in just a bit here. What it does and why it's practically useful for us in terms of frame animation or frame animating a Bezier curve. So the first thing is that we'll want to make sure that everything is deselected. I just toggled A twice, and with my cursor in the 3D view viewport area, and we'll go ahead and add a curve. In this case, I'm going to go ahead and just stick with the simple circle. I'm hitting the period and the 7 button, and there we have a top-down view of the circle. I might go ahead and scale this out here just to give us a little more space to work with. I'm going to check the data really fast to see how far we are scaled. So approximately with my script, with the scaling, probably about 6.8.08 is good. And I'm going to go ahead and make sure that the scale transformation is applied. And that is just by hitting the object and then apply and scale with the Bezier curve selected. Now in this case, I'll go ahead and start to explain the script and what it does and how it is practically useful for this Bezier curve animation. And if you have any familiarity in Blender, working with Blender and any sort of animating work, the one thing is that when you're working with animation, you're typically working in with what's be called, or what you may have heard as, which is keyframes. With keyframes, and if you look down here where I've got my cursor presently situated, I'm running my cursor along the frame bar. So you'll see this green vertical bar shown that's kind of moving left and right. I'm kind of left mouse button clicking and holding and dragging the cursor to the left and the right, and that's changing the actual frame. So at any given frame, we can set the curve, for instance, in terms of something of like its basic properties, which might include a location, rotation, or scale. Those are kind of some very basic properties that you can actually animate with. So if I wanted to animate the circle, for instance, and translating it up and down or on the XY axis, I could do so by going to a particular frame and then setting a keyframe, recording the location, rotation, and scale of the curve at that particular position. And so when you're animating, that's typically what you're going to be doing. Now with In the case of like curve deformation properties, where you're actually going and modifying the position of individual vertices on that curve, on the other hand, does require a little more work, because while in object mode, for instance, the mode we're in now, we don't have access to the individual vertices. And while we can translate, and I'll just go ahead and move the location of the curve here just by toggling my mouse. As you can see here, I'm just dragging it kind of left and right on the XY axis. The whole curve moves, and that includes all the vertices that are shown. But on the other hand, if we wanted to go in and like deform the curve by moving one of the vertices, the control points of the Bezier curve, on the other hand, we can't access that typically like when we're in object mode, or typically when we're animating curve data. Now, there is actually a workaround in doing that, and the workaround means that we actually have to create what we would create are called hooks on the curve, and those hooks would be attached to individual control point vertices of the curve. And those hooks, on the other hand, are shown in the object mode, and we can actually modify those hooks and in turn modify the curve. Now, as you may be familiar already with Bezier curve, and I'm just going into edit mode here, we can see the control points already highlighted and selected, but we also have left and right control points in addition to our central anchor point, or anchor control point. So if we wanted to actually animate the individual control points, we might also be interested in controlling the actual associated left or right control handle control point, and controlling the shape of the curve as we control as we also translate, say, its central anchor point. And the reason for doing that could be obvious in this context. I grab this curve or curve point and I change the control point. Everything is fine if I've got this in automatic with the control. It's the control points at the moment, the left and right control points, all of them are set to automatic, which means that it does take into account when you change the central anchor point, it takes into account maintaining a continuity of the curve. Well, the problem is that when we go to actually export this animation data, what we're actually exporting is the anchor point positions, which would represent where the control point is going to from the hook itself that we have attached to the control point. This is kind of an added complication in Blender, and something I had to work around that I discovered was that when you're doing frame animation data, it does not, the object deformation data, that is when we change the hook, the associated hook position of it, animating the curve and deforming it, on the one hand, that data that we might read, say, from like the edit mode of the curve, which is normally given, if you recall anything in my previous tutorial on the script, what I'm typically reading is the spline data that's coming out of from the curve, but that's the data that is actually that would be read in edit mode. And unfortunately, when you're animating in Blender, the animation applies to object mode. So reading the data, unfortunately, we would not be able to get from the spline, cubic spline data, at least as far as I've seen. There may be a workaround that I haven't discovered, but as far as I've seen, when you access the spline data, you wouldn't be able to get the curve animation data. In other words, it just stays fixed in space, even if you're animating from frame to frame. and accessing that cubic spline data. So in this case, what we actually have to read is the hook data, where the hooks are at. Now, if I set a hook simply to the anchor point, the central anchor point for each Bezier curve vertex, I would have part of that animation data, but unfortunately I'm missing another part, which includes the left and right control point data. And unfortunately, Blender wouldn't furnish, like with the when the control points are set to automatic, the left and right handles automatically adjust to ensure continuity of the curve. That data is not exported. So what we have to do is actually assign hooks to every single, not only the anchors, but on the left and right control point handles when we're animating. And to further complicate matters, what I'm working with is perhaps a little more simple. Again, there may be a workaround in doing this, but when we have the control points set to automatic, the hooks are not bound to those control points and automatically adjusting to wherever, for instance, if the central anchor point changes, the associated left and right control point hooks would not translate in like kind. So what we have to do is, what I've discovered is actually that you can work around all of this by creating not only hooks for all the control points, but assigning the control points of the curve so that they're free to float and not automatically assigned by Blender's algorithms, so that we can record that data and necessarily import it into processing as we're doing the curve animation. Now, what I'm working with right now with this curve, this may not seem like a lot of anchor points. In fact, we only have 4 shown here, but if we include the left and right points with each control or anchor point, then we actually have a total of, it's 3 times 4, which would be 12 hooks that we would have to add. I did find that that was a bit cumbersome, and adding even just for a small curve and the points that were added, or the existing anchors that we have, that was a little bit of work. And so I actually came up with the script that automates the process of adding those control points for you. That's the purpose of this particular script that I have, which is called Bezier Vertex Select Hook Add. So I'm going to go ahead and run that script. Again, I've loaded it in the text editor, and I'm just going to kind of toggle my middle mouse wheel. You can kind of roll the middle mouse wheel on this bar here, where my mouse is shown, and that'll move this bar left and right so that you can see the run script function there, or button. And I'm going to go ahead and run the script, and it looks like, lo and behold, we do have an error. It's saying curve object not found. So I've set up the script. If you may notice, it's designed where it says, I have at the very top, it says OBJ, and then the underscore, and then it says list and equals curve obj. So it's looking actually in the scene data, looking for an object called curve obj, but that's not there. So we actually have to change the name, or we would have to modify and turn the script to find that object. So I'm going to go ahead and rename it to curve obj and get that settled for the script. And lo and behold, we should have, once we've done that, all our hooks assigned. Now it looks like for some odd reason we don't have our hooks properly assigned, so I'm going to go ahead and select all of these hooks real quick, delete that, and make sure we do this right. So let me get back in object mode. I'm going to disable that so that we're just showing the object or the hooks, and I'm going to go ahead and delete those real fast, and that'll take care of that. And then I'm going to go ahead and re-enable that so that we can see it. And for some reason we have this hook data still assigned, so I'm going to go ahead and delete the object real quick and re-add it, since we're working with the basic Bezier curve. I'll go ahead and rescale this out, and I'm going to go ahead and apply my scale, and then we'll go in here and I'm just going to deselect all of these points because I don't know if that's what caused. Oh, and we need to rename this on top of that. Okay, now let's rerun it. Okay, so now we have all the hooks assigned. If we go into object mode, we can see that the hooks are all assigned to the given control points where they should be as it's initialized to the curve. Now the next part of this, the script, we move on to the next part, which is actually the animation part. So I'm also going to go into a little bit of a primer tutorial on handling actual in Blender animating of the Bezier curve, so you'll get a little bit of experience in terms of animation. I'll do a pretty simple animation sequence here, so it should be fairly easy to follow along in doing this. What I do recommend is that changing your view to something like an animation layout. So like at the top bar here, I have this choose screen layout, and I'm going to go ahead and set this up for animation layout. So I'm going to toggle this with the left mouse button and then click animation, and so now we have an animation. We've got our dope sheet over here, and we've got our hooks shown in the 3D viewport over to the right of the dope sheet summary. And I'll explain some of the things that really help here, because working with hooks can be pretty easy to do, but on the other hand there are some kind of key tidbits when you're doing kind of this hook animation work, kind of things to pay attention to. So the first thing is that we do want to go over to and I'm on my properties bar right over here, and I'm going to go ahead and select this square or cube icon, which is, I believe, our object properties tab, and that with anything selected like the curve, object, or any of the hooks, that data will be populated below where it says, for instance, under transform, that data would be shown. So in establishing animation, as I explained before, you'll want to assign what are called keyframes. Now in assigning a keyframe, we, for instance, if we wanted to animate this hook, and I'm going to deform this curve just briefly, you can see immediately when I change or translate by hitting the G button and translating this hook, that the curve is being deformed as I move the hook. So what I'm going to do is actually go back into the curve though, and we're going to want to select all of the vertices and go to control points under curve, and then set our handle type to toggle free align. And so this will allow us to now change the hook. Now when we change the hook, you notice we're getting kind of a heart-shaped symbol, or cardioid type of curve deformation. What's going on here is that the original control points associated with this anchor that's moving are still maintained in the same position. But if we go ahead and translate, I'm just going to do well, actually, we'll get into that in just a moment. I'll explain what you can do in adjusting the control point, but in the meantime, we'll go ahead and start our kind of keyframe data from kind of an original start position. What I want to make this animation do is run on kind of a cyclic course, meaning that it'll go back to an initialization state after it is done animating, so that we have kind of a looping animation that's continuous, that repeats itself, but you don't exactly know where the start and the beginning are. If you were to hit the play transport and have no idea where you had started in the animation sequence, they would all look the same, and in terms of the continuity going from start to end position, start and end position are the same state, same final state, and then we have some, perhaps in the simplest case of animation, series of intermediary states that move from one to the next until we go back to the initialization state. So we'll start with this particular hook that I have selected, which is hook.000, and we'll need to make sure that our frame is set at 1. You can tell the frame that you're at right down in this where it says current frame, where I have my mouse highlighted, current frame to update animation from Python frame set instead. So that should be at 1. And I'll go ahead and move my cursor over where it shows this object properties. And you just need to hover your mouse over, for instance, one of these fields like location, rotation, or scale. In this case, we want to record a keyframe data from this location set of the hook. So what we'll do is hover the mouse over one of the location fields and then hit I, as in indigo. And so once we do that, you will notice on the dope sheet immediately a keyframe data populates, and what that includes is the position state of the hook that's being recorded at that particular frame state. Now, what we'll go ahead and do in this case is fast forward to 100 frames. And before we do that, we may want to decide how long our animation is going to be. So in this case, maybe we'll go ahead and keep it quite simple and go to, say, 200 frames with that data. So I'm going to go ahead and set the current frame. I've just highlighted this current frame field, and I'm going to hit enter, and that automatically fast forwards us to the 200. So again, if you just left mouse click on this and type in a number and then press enter, that will go ahead and fast forward the frame to a particular frame position there. So what we'll next do is want to record the position state. So we can actually select, and I'm just waiting here for a second. So we can select that keyframe data. I just hit the C button, and you can left mouse click on that location data. That's one way to select a particular keyframe data position, and hit Control C, and then you'll hit Control V, and what we have populating is the keyframe at the 200 frame position. So we can see that on the both the dope sheet summary and this hook animation data set down here. So that is important that you kind of have some end animation frame state in mind when you're doing this. Now we'll go ahead and set an intermediary animation position, and so I'm going to change the frame to 100, and we'll want to go ahead and animate this the change in the state of the curve for this particular hook. So what I'm going to do is hit the G button and then hit Shift Z, and then we'll change the hook so that it kind of goes into a cardioid position. as I explained before. And so when we do that, we'll need to actually record the animation state of the hook at that position. So we'll go ahead and run our cursor back over to the transform properties where my mouse is shown presently. And we'll need to go ahead and hit the I button again. So now we have an animation already set up. And what we can do is hit the jump to first frame and on the transport, and then run the animation sequence. And so what is going to happen is that you're seeing the curve animating from a start point to an end point, and then going back to the start point, and then looping on a given cycle. And we can choose the end of that cycle at 200 to loop it to after the 200th frame, so that we just start right back at the beginning beyond the end cycle at 200, and that's choosing the end field here and typing in the 200. And so now we're kind of looping between these animation states. Now, as I explained earlier, we may want to go ahead and, while we're animating this, go ahead and change one of the control points to smooth out the curve so that maybe we don't have kind of this cardioid look. And if you're wanting to maintain kind of a continuity in the curve so that it's point-wise smoother, and not discontinuous, like for instance at that particular point that represents the kind of the merging of the two curves, and that have two different and when I mean continuous, if you have any familiarity with calculus or analysis, what that means is that the derivatives coming from the left and right as you approach that particular point, they approach the same. The derivatives are the same as they approach that point, or when they hit that particular point. Well, at the moment it is considered a pointwise, I believe, discontinuity. So if we want to smooth that out, we can actually control that. So what we'll want to do is first grab one of the hooks, and we'll procedurally repeat do the same thing that we did before, which is hit the I on the hook, and I'm just grabbing the right control point left handle, or the right control handle on that relative to that anchor. And I'm going to go ahead and record the keyframe of that anchor by hitting the I button under the location with the hook selected. And we'll want to go ahead and record that. So the I'm running my mouse cursor over in this field right here. It just needs to be on the field. You don't need to be on the points. The points are selected. The keyframe points are already selected. So we'll just hit Control C while we're in this field, and then we'll advance our frame to 200, and we'll just move our cursor back over to the field and hit Control V, and lo and behold, we've recorded a start and a final and start position there. So now I'm going to go ahead and move the frame to 100, and I'm going to actually adjust the anchor, or this right control point anchor. So I'm going to hit G and then Shift Z, and what we can see by adjusting this down is that at some point when we pass the threshold where we're down, at some point we have a more continuous curve, smoothing of the curve. So I'm going to go ahead and hit the left mouse button and release, and that will establish the hook where we want it. And then we will move our cursor back over to this location field, and we hit the I button to record the animation state. So then we'll hit on the transport, go back to the beginning, and we can actually verify that both hooks are now moving for the animation sequence. So what this is demonstrating, I'm not going to go into necessarily animating all the hooks here, but I did want to show this establishes how you would go about doing basic animations. So you're going to be working between this field and this field, and then selecting again one of the hooks and establish kind of a start, end state, and then intermediary state when you're doing animation work. So if you like the animation, in this case I think it's good for what I want here, we'll go ahead and change our screen layout view, and we'll need to go back to our default view. And in this case, we're going to pull up our other script, or verify that it's pulled up. We want to go to Bezier Curve Data Read 3, and what we'll want to make sure, and I've gone ahead and in this case for this tutorial and my script in general, just kept it for one curve object. If you had many, the nice thing with my script is that you can import multiple curve objects and animate simultaneously multiple curve objects, Bezier curve objects, as you're working in Blender, for instance. So that is kind of a nice thing to keep in mind there when you're working with this curve data. Now, as I've stated before, when we're reading the curve data, unlike in the previous tutorial where my script actually read just the spline data, I'm doing something a bit different here and not reading the spline data, but only reading the hook data, and that's just by tracking the actual object hooks that we have recorded. So you would ultimately need to supply, I believe, the hook data. Let me make sure I've got all of this. Hook list I don't know if I should have recorded this, but for some odd reason I don't have it shown. And that kind of bothers me, because we will need it, and I don't know why the data did not get saved. So let me, I'm just going to toggle, and because I'm afraid that we may not get a proper data read here real quick. So I'm going to pause this for just a second and just check on this real quick, because we should be reading not only just the one, because we're reading the hook data here. So let me go ahead and save this. I'll just save it as untitled. See if I can pull up my other. Okay, yeah, for some reason I'm not showing. I didn't, for some reason, save. Maybe I didn't. Okay, I think I need to save this real quick. It's Bezier Curve Data Read. Okay, let me see if it repopulates in my other, that we just, the other tutorial, in just a moment. Let's see if I can reload it if necessary. Okay, yeah, now it's reloaded. So yeah, that should be oops, that's not what I wanted though. And let's go back to this curve data read real quick. Okay, yeah, now it's reloaded properly. What I was seeing there was that I wasn't reading the points data as I was hoping here, where I was supposed to be reading the hook data, and I was seeing that I was reading the spline data. So that does need to be adjusted, or that needed to be adjusted there properly when we run the script in order for it to run properly. So if we like the animation, again, we go to this Bezier Curve Data Read 3. If we like what we're seeing in terms of the animation, I'll just run it one more time. We can see that over in this other frame, we can see the hooks moving and the curve animating in consequence. And one other thing I just comment is that when we're doing animation in Blender, the nice thing with animation work is that they handle the interpolation processes of animation. So you can actually change from cubic fall-offs or a whole host of different types of interpolating fall-offs, or you can go to a linear interpolator. You could, of course, program that in processing.org or your processing script. But the nice thing is that Blender's already got the step program, and it's kind of like, why reinvent the wheel if you can graphically work with your Bezier curve in terms of all the animation states, and instead of trying to figure out where something corresponds to what corresponds to what, and then handling all the interpolation work on your part with the coding. Blender will do it for you. So that's one nice thing of working in Blender, and then exporting that animation data. So if you like what you see, in this case, we can go ahead and we should be able to just run the script, and just with the click of a button, it exported all that data to the CSV file. Now the nice thing is if you recall from the previous tutorial, normally you would have to copy and paste all this data. I've changed it so that you don't have to do that any longer. If you use my file, you would need to set the file path to the given necessary folder wherever you download the processing script. That folder that you have it downloaded, you would need to copy the path and put it in this file path necessarily. I have a Linux, by the way. I have this file path set up for Linux. I believe in Windows, and it's been a long time since I've used Blender or it's been a while since I've used Blender with Windows, but the pathing may be a double backslash when you're going from one directory to the next. So, for instance, if you're going my processing directory, it would look like something like this, and then given by the file name of the name of the file that you're writing to, which is the Bezier point CSV or .csv. But the file path string might look like something like that in Windows. It's been a while since I've used Python with Windows, so I'm not quite sure, but that I am pretty certain that it is different from Linux in terms of like when you're working in Python, the file path string process there. So in any event, the data is now imported and it should be ready to go. So we can just hit with the I've already got the program, the processing program pulled up. I explained in the previous tutorial how to launch processing. And they have also like getting started on how to do that. So I'll skip over that, but in any event, I've also got the debug toggled on, so in case the script fails for whatever reasons, you won't have to figure out how to close out the script. So I do recommend running in debug mode, and go ahead and hit the play button here, and we can actually see. Actually, I'm going to toggle this real quick so that we can see the curve animation itself. while we're watching this. And let's see that we can change that by going to show track 2. Don't mess with show track. Show track 2 is the one that we want to adjust. And we can see the curve as it is animating back and forth, oscillating back and forth. And then I have kind of this really rapid and short deposition of little Bezier curve segments as we're path tracing on that. This kind of reminds me a little bit, almost getting close to the yin yang, the Chinese symbol there. We just need the circle or the dot in between the two states there. But in any event, we can see that the animation is working and the effect of it when we're animating between the two. As explained in one of my Google Plus posts, you may notice that kind of what's cool about Blender and animating with the quadratic fall off, a quadratic type of fall off and going between animation states is that we actually have an acceleration and deceleration of the curve as it's animating between two states. So the effect of this is that the areas that are time-wise more heavily populated are the areas where it's undergoing deacceleration and then coming to a rest and then reaccelerating. So we get kind of a cool shading relief and using kind of Blender's native and basic interpolator and doing that, which is kind of cool for kind of graphic arts work, but that mathematically that's what's going on and why you're seeing kind of these cool kind of darker profile outlines outside of the center of the animation, like right in this area relative to these edges. But in any event, that demonstrates for the curve. I'm not going to go exactly into all of the code work that I did in getting this set up. I felt that I needed to create some sort of hash mapping system in keying the data, especially by frame and by curves. This is almost like SQL work, but I had to translate it into hash maps. Maybe there's a way to import work with SQL out of processing. I don't know. It might have come in handy because technically I was using kind of like a searching by frame and finding points off of my table data, CSV table data, and keeping those points organized by frame and by curve, and then kind of using kind of a set intersection. Well, actually, I don't even think I did do that in the end, but I was thinking, well, maybe I need to do a set intersection between the frame keyframed the frame ID being keyed. When I pulled up a particular frame, I would pull up so many points that were associated with that frame, and then at the same time simultaneously pulling up for a given curve ID, pulling up all the curve data and then taking the set intersection between those two search queries. It's kind of the same exact deal that you would see in SQL, but I opted to instead not use something like that because wasn't exactly sure how to interface SQL with processing. But in any event, that handles the scope of what I wanted to cover in this tutorial. The scripts are free for you to download and use. You're more than welcome to use them. I encourage you to use them and explore and discover and have fun. And thank you for listening in this tutorial, and you have a great day there.